I was on mute. How's everyone doing today? Do a little start early office hours. I tell you what, these contacts, I can't wait to get some new ones because that contact just doesn't want to do what it wants to do, or it's doing what it wants to do, not doing the right thing. Okay, so we're going to get started here with a little 320. So I want to talk about their assignment to start. But if you have questions, put them in the chat. I will be doing more office hours in a little bit. I've got a meeting, so I had to break up the office hours today. So let's see right here. Come on, do your thing. See the screen clear. There we go. Now stay looking this way. Okay. So we are at 153, BAS 320, assignment 3. Let's go talk about it. Here we go. So we're using Kaggle for this third assignment. So Kaggle is a site that hosts data competitions. Really cool. If you go to the competitions part of it right here. So here's the competitions, all this right here. Here's the first and future player contact detection right there. So let's take a look at all these. I need to increase the size. GoDaddy, micro business density forecasting, whatever. Ooh, so it's like website stuff. Learning equality curriculum, Lux AI season 2. Predict student performance from gameplay. Wow. So lots of really cool stuff going on right here. And these are all competitions with real money. Hey, Sloan, good to see you here. If you got questions, put them in the chat. We can do a little 2-1 right after this. I got a meeting at 1 p.m. your time. Should be noon my time. I think the calendar keeps up with it. Titanic. So here's actually real Titanic data, which is really cool because what you can do is go to the data on this. So we can go to the data right here. We can actually download the data, and they've already got a bunch of analysis on it. So we're going to download the train CSV, gender submission CSV. Let's go to train. We just, it shows us the data. Got some quantitative data. Good to see you here, Angie. And if you have any questions, let us know. This is the data. You can actually load it up either inside here. We'll download. Download. Can we just download? Download all. Here we go. We are downloading the data, and we're getting it from Kaggle. And it's pretty easy to navigate. You can get NFL data from here, all different data sets. Here we'll call this, here we'll go here. Sure, I might have a train and test. I'm moving it to my downloads right now. So it's called train and test. I should not put in my contacts ever. Okay, I think I've done it. So here we go. We're going to take a look inside of R. And let's go read.csv, train.csv. And there's the file right there that looks right. And I think we've done it. Is this the Titanic data? It looks to be. Oh my gosh, those Titanic people? Yeah, there it is. There's the Titanic data. So we can start doing some visualizations on, we got the class, if they survived, their passenger ID number right there. So Titanic right there. And now we have the Titanic data. So for my students who are doing this assignment, this is 320. Don't use the Titanic data. You're not allowed to use, someone's like, oh, darn it, I really wanted to analyze Titanic data. Don't do that right there. We got the names. Wow. The sex, the age of the individuals. NA means it's missing. We don't have data for that individual on their age. Sibling, spouse. That's how many siblings maybe they had. I don't know. Usually there's a data dictionary for these that tells you the information. So usually we're going to see some sort of thing telling us what these columns are. Data dictionary. Here we go. And number of siblings, spouses aboard the Titanic. Number of parents, children aboard the Titanic. So did they have siblings? Wow. Ticket number, passenger fare, cabin number, embarked port that they had. So all this information is contained in the Titanic data set, which is pretty neat to think that we have a lot. Those that have been over the data analytics have been very helpful since the data analytics series doing a week from day. It would be something good. Yeah, we could do that here, Sloan. We could do that next. You got it. And so this is data analytics right here. We could talk a little bit about data analytics 3, because actually I think that's what my students are doing in 320 to kind of bridge this and talk about what they're doing and what you're doing. So let me go back to 201, and then maybe we'll look at the Titanic data here and talk about what data analytics 3 covers, because I think it's mosaic plots, right? If I am correct, data analytics 3 is mosaic plots, right? Bivariate visuals right there. Bivariate visuals in a week. Bivariate visuals. And I do see party and gender right there. Yes. So there is a mosaic plot and contingency table. So this is not quite how to do it in Jump. Never going to see again, am I? Never going to see. For the one due tonight, Angie, and are you in one of our sections, Angie? If you're in one of our sections, I have it linked, and I'll drop them in the chat right here as we're talking about this. But if you go to the assignment, I put the link right here, and I'm going to drop it in the chat now. So data analytics 2. So it's currently in the chat. So you can see it right there in the chat. That is data analytics 2 in the chat. Come on, contact. So there it is right there. And it's also, I marked it in our assignments and how to turn off dark mode if people are having dark mode issues where they can't see the numbers. You're welcome, Angie. Right eye is the good eye today. And so, Sloan, what we're thinking about is if we want to do mosaic plots and contingency tables, we actually need categorical data. So, Tena, thank you so much. And we'll probably do a more exact way, but this goes to 320 right here and is doing a bit of their assignment. So, a lot of these right here are categorical variables. These are characters. That's the number of parents. That's the ticket. That's the fare. That's the cabin they're in. That's the embarked. Okay. So I need to go here and do the following. With the Titanic data, there's another Titanic data set, so I gotta be careful. There's like a native data set inside of our. Survived is going to be a factor. So watch this, 320 will understand this, is you'll see this is gonna turn into a categorical variable right there. So now does that make sense, Sloan? I made that a categorical variable. It was quantitative, but it's not a quantity of surviving, it's did you survive? So a lot of coding is copy pasting. So all we're going to do is we're going to go back here and change class over to a categorical variable. But we might actually go ordinal because I think let's look at the class really quickly. It looks like 1, 2, 3. I don't see any 4s, which is interesting. So we want to go to ordered equals true. And that makes it an ordered categorical variable. So that's an ordinal variable. So now we have an ordinal variable created. We want to make the embarked also. So this is like your first steps in fixing data. And I think that's it. I think we've done this now. We have embarked has 4 factors. There's no order to embark, so that's a nominal categorical variable. And now we have it. So what you can do after you got your data all nice and neat over here, and like I said, we got a missing value on someone's age. You could go over here and see if there's an association between surviving on the Titanic and someone's age. So we're seeing, is there an association between surviving on the Titanic and someone's age? So this is the associate function, and it's saying, does somebody's age explain their survival? And I can bring this data over to jump in a little bit. And here we are right here. And it actually is doing age groups. Oh, wow, that's interesting. I didn't expect. So you actually get the mosaic plot and contingency table here, and 1 means survived right there. We could recode it. Ivan, good to see you here. Let us know if you have questions. So you can see the most likely group to survive right here was people who were a lot younger, 0.42. They did a very exact calculation on someone's age right there. But then we could let's look at sex. Oh, we didn't change sex. Sex and survival on the Titanic. So here we go. We're just going to change this to a categorical variable also because it's going to be groups. So what categorical variables are. Really? There we go. And now we're just going to change the X variable to sex to see if sex explains survival. And look at that. What do you notice right there, Sloan? And this is big stuff right here. Now, were there more males or females on the Titanic? This goes to a mosaic plot and knowing how to read it. Were there more males or females on the Titanic? On the Titanic, were there more males or females on the Titanic? What do you think? Were there more males or females? There were way more males. It was like 65% males. And I really like how we get the scale on the bottom right here. So the scale on the bottom shows you the marginal display. And we can look at the marginal display of gender. And you can see about 65% males right there because 35% is there. And the 35% would be 35% female to 65% male. So that's the marginal display, which is important to mention. Great job right there, Ivan, also. And so now also, I'm just going to do that over that. Did more people pass away on the Titanic? And 0, you know what we're going to do? We're going to make this a little bit easier to read right here. We're going to go right here and go to survival and say Titanic survival survived if else I'm gonna put a factor if Titanic survival equals 0, then died else survived, and then we go here to factor, and we could have done that from the start. Oh, what did I do? Oh my gosh. There we go. That's a little bit easier to read. And that's what we like to go for on our graphics is we're always trying to go for the best and easiest to read graphics where someone doesn't have to know what 0 and 1 are because class makes sense as 1, 2, 3. We understand first, second, third class. And then right here, we actually have the data labeled now, and that required a little bit of kind of recoding with an if else. So it's pretty clear to see that more males died than females, and this is a very strong association, unlikely by random chance. This last bit right here is really where we're going by the end of the class with the chi-square test of independence, and my 320 students should know how to look at the p-values and stuff over here, which is estimated to be about 0. You can also tell that if someone was male, they had a 81% chance of dying, and if someone was female, they had a 26% or 26% of females. And we're just doing a little rounding on the numbers, but these are known as the what. Hey, Andrew, good to see you here. These are known as the what distributions, like given someone is female. These are known as the what distributions. And it looks to me there's a very strong association. Like given someone is female, this is 25, or no, that's the top one. So what are these known as? These are things 201 should know. What are those known as? It says it up above it. Those are known as the conditional distributions. So you see right here it says the conditional distribution of the y variable of interest based on the x variable sex. So we can see here 25.7% of females passed away versus 74.2% of them survived, and that's where the 74.2% would be there. We can see the same thing for males, and this is the marginal, which is for everybody, which is over here on the margin. So the margin for survival is in the margin as it is on the table. Very important to know this sort of output. This is not the one you would see for your class for 201, but this is what we're doing for 320. And I downloaded this data set from Kaggle, did a little bit of cleaning with it, so I had to kind of fix up the data there a little bit. And yeah, just you got to make sure your data looks right because not all data downloads correctly. So you might do a little fixing on the data to begin with for your data set. And that would be an analysis right here. So don't do the Titanic data. You're not allowed to do the Titanic data. Maybe if someone says, hey, Brian, I've already done a whole thing on the Titanic, let me know. But what's really cool about this, and this is the last thing I'll say, then we'll switch topics. We'll go over to Data Analytics 3 for 201, is you can do a whole big model right here. And watch this. We're just going to go to a model we're going to make right here. And with this model, we're going to take a lot more variables. Let's look at survival on the Titanic. And there's survived, tilde. And let's look at passenger class plus the sex of the individual plus the age of the individual plus the number of parents they had. Hey, Sam, good to see you here. Let me know if you have questions. Plus their fare plus their where they embarked. Okay. Now we're going to have to do a little change. We're going to say family equals binomial because we're actually doing logistic regression. Binomial. And then data equals Titanic with the capital T. And we're going to store this into a model right here. Oh, doesn't like it. Not meaningful for factors. What's it mad about? Survived. What is it mad about? This will be our last example right here. Let me see. Oops, I want to keep that. Oh, it's a warning. Oh, okay, that's fine. I didn't notice it's a warning. Warnings are usually not that bad. Okay, let's look at a summary of it. Oh, that's bad. That's bad. Not meaningful for factors. Error in quantile, unordered factors are not allowed in addition. There we go. P-class, sex, age, parch. What ones are characters? Am I about that? Name? No. 2 seconds right here. This is, I'm like, why does it not like it? Oh, well, now it shouldn't be family binomial. Ooh, it's super mad. It's survived. It's getting mad about survived. Oh, well, we do want family. Oh, is it mad about the family binomial? Did I type that? It looks like that's what it's mad about. Oh, I think you have to do that. No? Oh my gosh. Okay, I know what I did wrong. The answer is it's not LM, it's GLM, generalized linear model. There we go. One mistake, one letter off in coding, and everything goes haywire. Brian forgot we're using the generalized linear model. I was like, okay, what's it mad about? It wants the generalized linear model, not the linear model. Linear model can only do quantitative wise, where the general linear model allows you to choose the family. You're no longer using the Gaussian. You're using the logistic model, which is what I wanted, and I just forgot the G. So if you look at what's statistically significant right here, the most statistically significant thing was somebody's gender. And then we look next, actually their class. And yeah, we got different classes right there. And then we have somebody's age. Everything else really didn't matter. So let's eliminate this down, which not the best way to do stuff. And what percent? Well, it doesn't show. Let's go down here and just do their sex, their age, and these other things don't really matter. The fare, how much they paid, because fare is probably highly associated with that. And there we go. Wow, those are super significant now. So this would be a model to predict if somebody survived on the Titanic. And the level of interest, I believe we're talking about survival, because being male made it less likely to survive. So it would be female, and it looks like it would be passenger class Q is the most likely, or you don't want to be in passenger class L, whatever that was. And then you would want to be the older you are, the less likely you are to survive. So a baby in first class, a female baby in first class, which is, I think, what we would think. This is not required of this first assignment, but female first class babies had the highest probability of surviving on the Titanic. I'm not doing any groundbreaking work right here, but that's what we're getting from this data, from this analysis. Other things were not statistically significant, likely due to random chance. Okay, let's talk about assignment. Let's talk about the data analytics 3. Sloan, is that what you want to do? Data analytics 3? Some data analytics 3. So 320, download your data sets and start your analysis. It disappeared off the screen. You want to get your analysis going. Yes, let's do it. My right eye sees perfect right now, and my left eye is just all blurry. And I hate that. I've got new contacts coming in. I literally just put in a new contact this morning. All right, 2 seconds. It's funny, I see better with my contact out. It's horrible. There we go. Now I can see for the moment. Okay. Well, a lot of days I'm wearing my glasses these days. Yeah, I know. No, really. It's I went and had an eye appointment in early January before classes even started. And then they were like, oh, your contacts will be in February. And I haven't heard back from them yet. And I'm like, really? Really? And I think it's led to headaches and stuff like that. A lot of eye strain. So I'm like, when are you going to just give me my contacts in? Or when are you going to call me? It's a bummer. It's a bummer. So let's head over here to data analytics and let's do it. Okay, so we got data analytics 3. Let's do the whole thing right here. Data analytics 3, stat 201, data analytics number 3. So what I'm going to do for this is I'm actually going to analyze the Titanic data that we got. So I'm going to use completely different data than you. So give me a second right here. I'm just going to save this as a CSV and open it inside of Jump. Once again, we use Jump for this class. So write.csv, Titanic. There it is, and Titanic.csv. Let me go over to Jump. File open. It should open a comma separated file. And there it is. Or really, it's going to open. Okay, I'll just copy paste it then. Okay. There we go. I now have the Titanic data inside, and let's take a look at it. So with the Titanic data right here, which you're not analyzing, you're going to analyze your data. Make sure to go with your data right here. You get the political party data set right there. Take a random sample of 200 plus the last 2 of your UTID. I would follow up with them. Oh, in less than 2 weeks. Yeah. Minor special order. Thank you, Sloan, right there. Thank you. We haven't thrown points today. Yeah, no, I need to probably call them up today after office hours and be like, hi. I called them up and they were like, yeah, they'll be in. I was like, okay. Called them up like 2 weeks ago. Like early February, and I was like, okay, it's early February now. It's about mid-February. And so with this right here, we need to do a random sample of 200 plus the last 2 of our UTID. So let's go over here to Jump, and let's go here to tables, and let's go here to subset. Under tables subset, yeah, Brian, thank you, Sloan, right there. Let's pin that also. We're using table subset, and so you won't be using the same data set as me. And I'm going to take 2 plus the last 2 of my UTID. Make sure that's the last 2 of your UTID, whatever the last 2 of your UTID is. And do click it. You don't have to click it, but I've had some people do selected rows by accident. So I noticed in the last video, a few people said, wait a minute, I'm only getting 1 row. So do click it. It's just when you do this, if you go table subset and you type the number in right here, if you watch really briefly, I've got to pause the video, it actually goes there and does it for you. So make sure to click selected row or select this number of rows. So let me show the process one more time for those wondering, and then we'll start making contingency table and mosaic plot. Tables, subset, random sample size, 2 plus the last 2 of your UTID, click it just to make sure, and then click OK. Awesome. Now you'll know you're using your random subset if you see down there that you have a random subset of 2 plus the last 2 of your UTID. Once again, as Sloan said right there, we are using the Titanic data because the Titanic data is interesting and it's a different data set than yours. So if you know how to analyze data with these techniques, you can do it for any data. And that's our goal in this class, is to teach you how to understand and analyze data. So here's what we're going to do. Let's look at the assignment. Now, my number one advice is I take a note right here. So where's my note? So there's the Titanic data. Getting started. And we are currently at 22:43:33. Stat tool 1, data analytics, 3, mosaic plot. And oh, my boss just talking away in the chat. So make sure to look at the rubric. This is how the graders grade you. So if you're wondering, am I getting the points? Put your name at the top. A lot of people forgot that for the first assignment. Not the end of the world, but make sure to put your name at the top. Very important. Random sample was taken. We just did that, so you should be good. Make sure to do 2 plus the last 2 of your UTID. Mosaic plot visualization. Proper screenshot of the mosaic plot with the totals and columns removed. So we need to remove some stuff here. And from the contingency table, so there we go. And so let's start doing that here in a second. Mosaic plot relationship, write up describing the nature of the relationship between two variables, including numeric information to support. A lot of people forget numeric information right here. A lot of people just say, hey, it looks like this, and they don't give any numbers. Numeric information is going to be super important. And then you might have one with minor errors or doesn't give enough information. So make sure you are supplying enough information. So you will be doing gender and party right here. Take a screenshot of this right here, and I think we're good. We're good to go. And then the coaster data set's the next data set, and you'll do 100 plus the next 2 of your UTD for the next data set. So we'll kind of do that when we get to that. Okay, so here we go. Good to see her, Sam. With this, we are going to go to Analyze, Fit Y by X. Analyze, Fit Y by X. Under Analyze, Fit Y by X, you're doing a bivariate relationship. If you notice here, some of these are red. Red means they're categorical. Blue means they're quantitative. If you do categorical, you get this mosaic plot right there. Not exactly that one, but you get a mosaic plot and you get a contingency table. So if you notice here, red and red line up to this. Here's side-by-side box plots with blue as the Y variable and then red as the X variable, which is categorical X. And then logistic, which you saw if you watched my 320 video. And then blue and blue is bivariate quantitative, which is scatter plots, which is going to look at correlation and regression. So with this right here, we can go and see if somebody's survival on the Titanic was dependent on their sex. So with this, here's what we get. And we're going to clean it up first here. So I put the 2 variables in, then clicked OK. You should see a mosaic plot there. We're going to go right here to the red arrow and remove total percentages. See what it says. And column percentages. Total and column percentages. There we go right there. Total and column percentages removed. With total and column percentages removed, we're going to click right here on this tool. Now, it might be hidden on yours. You have to click up here somewhere, or you might have to go all the way to the top. This is going to make it look really pretty right here. Click this one time. This is the tool between the question mark and that. It's called the selection tool. You want to just click that one time, let go. And after you click it one time, don't have that come up, move it over to here. You'll see a long bar appear right there and let go. Perfect. Now, the reason I did this is because when I take this screenshot, I'm going to go back to the little mover tool. This screenshot looks excellent. Now I'm going to get the screenshot nice like that. And let's just remove this. Cool. Awesome. And now we go over here go. Hop over here, drop it in, and do the final crop on it. And this just makes it look really pretty right here. There we go. That's going to be our great screenshot right there. And if you want, you can always throw a border around it. Once again, clicking the picture gives you these options. Doesn't hurt. That's looking stellar right there. As a screenshot, that's about as best we can do. And you don't have to make them perfect, but you don't want to take full captures of your screen. Remember, this is meant to look like a semi-professional report. And yesterday, check out yesterday's office hours. We went super in depth and did one and looked at the difference between jump and R if you want to see what is possible with pie charts. What would you say to explain it? Great questions. Because now we're in the explanation phase, right? The only thing I don't like about this, it's not the end of the world. I'm going to redo it really quickly right here. Because if you hit Control minus, Control Shift minus, you can zoom out a little bit. Oh, really? There we go. Oh, I don't like that this survived right here. Can I fix that? Might not be able to fix that. Well, I'll be. I don't like that it says survive D. Huh. Well, jump doesn't let you edit everything. That's a bummer. I'm literally trying to figure out how to edit that one thing because I don't like it. You could change the name of the variable, but, well, it's a bummer. That's why I like coding sometimes, because I can get exactly what I want. But here, let's go back to our Word document. So it's not perfect, but we have to deal with it. Okay. So what would we write? Well, we need to talk about there's a relationship right here. Well, first off, what can tell us if there is a relationship? The what distributions. So this is the learning objectives right here. A relationship is probably best shown by looking at the what distributions, Sloan. If we compare the what distributions in here with numbers. A relationship is probably best shown if we compare the what distributions. If we compare the what distributions, we could probably talk about there being a relationship or not a relationship. And I've got them highlighted with certain colors right there. We could talk about how many people we sampled. So we could talk about the amount we sampled right there. That's the amount in our sample. We could talk about how many people survived, how many people died, how many males there were, how many females there were. But this is going to be the real important stuff inside of here. What are those called? Like, given someone is female, given someone is male. They might be called that. That might be another name for it. I got 3 points. Called conditional distributions. Conditional. So given someone is female, what's the probability they survived? And that's what I've highlighted in yellow. And you can see where it connects. More importantly, we should be able to connect the ideas in the Mosaic plot in the contingency table. This is the marginal distribution of survival. So here's the marginal distribution of survival on the Mosaic plot. And here is the marginal distribution of male-female, where we can see there were more males. And here's the marginal distribution. Now, the bivariate combination inside the table, looking at if someone was female and then the probability of survival, is going to be the conditional. So these are the things to talk about. The most important thing to talk about if there is a relationship or not is going to be the conditionals. You could mention the other ones like the percent of males, the percent of females, the percent survived, the percent died. But when we look at this right here, we really need to focus on the what's to talk about there's a relationship. To talk about if there's a relationship, we really need to focus on the what. Might even compare this, which would be the difference between, we could look at the survive. That would be, really? Is it that? So the percent of females who survived is this. Oh, wow, that's a big difference. It's a big difference. I would get that number and mathematically take it and say the difference in survival of males and females was about 54%, 53.97. So that's a big difference in survival rate. How is this making sense, Sloan, right here on what numbers you would talk about? Like 67 of the females on the Titanic, 14 was roughly. Yes, from our sample. You could say from our sample. I'd probably say from our sample. Yes, and then you would compare that to males. Does that make sense? So you'd then compare that to males, and you would say, comparing this to the males, there were this many in our sample from the males. Exactly, Sloan, right there. So that's the kind of things we're looking for using the numbers. And then you could then take the difference right here, like I just did. So you could compare the percent of females who survived versus the percent of males who survived and talk about the difference right there. And does that seem like a difference that is small or a big difference? We talk about when our difference is small, like there's no difference. Does this look like a no difference, weak difference, or strong difference? What do you think? Like the one I have on the screen, does it look like no difference, weak difference, or strong difference? So there's the one on the screen again. So it look like the association or the relationship. So does the association here look, it looks very strong, right? We would say there that these two things are not independent of each other, that there looks to be a dependency, like someone's survival on the Titanic depended on their sex to a certain degree. It's not like your sex determined if you would survive, but it was associated. Like if you knew someone was male on the Titanic, if you knew someone was female on the Titanic, they'd be more likely to survive. So that's what we're going for. So any questions about that? These numbers are the key. Like, know what these numbers mean. Those are 47 females survived out of the 67, which is 70.15%. And then know how it relates to the Mosaic plot. These are the learning objectives right here, where you have the marginal distributions, and there's the marginal on the Mosaic on the contingency. Here is the marginal on both respective. It gives the same information showing you less survived, and that's the numbers right there. Here is the within. So if we show where that is on the plot, because you should know where to look on the plot to see the same information. That's everything within. And then once you look at the withins, you could go to a condition of condition female, or you could go to condition male right here. So understanding how to look at this and understand that it's the same information being displayed over here graphically for you. Does this make more sense, Sloan? This is why we have these assignments, so you can have practice doing it. And this is what people use is, you know, could you imagine somebody putting a report or putting a graphic like this in their biology report, their management report? Like, hey, if you put a graphic like that in a report, teacher might say, where'd you make that? How'd you do this analysis? And you say, oh, I learned it in step 1. They say, yeah, but they should have taught you not to do that. And you say, oh, no, well, Brian couldn't fix that, so I couldn't fix it either. Yep, exactly. Exactly. These write-ups are your practice and your examples to see how they apply to different data sets and how you can use them. Because we're a lot of times not going to sit around and find these numbers by hand. We can use statistical software to get it. Hey, Simone, good to see you here. Ask questions if you got it. We've only got like 18 more minutes, but let me know if you got questions. So we're on to the next section of the video where we're going to do some side-by-side box plots. Stat 201, Data Analytics 3. My vision is perfect now, Sloan. Data Analytics 3, side-by-side box plots. So it's very important when you do side-by-side box plots to know what kind of data you're analyzing. And let's go look at the instructions. Once again, please read the rubric to where it says things like take your random sample. We're going to do 100 for this one. And then side-by-side box plots, and you're using the roller coaster data. So make sure to get your data. Use 100 plus the last 2 of your UTID. So we're going to do another random sample here again. Submit the Word document with your write-up. You'll include both in the same Word document. And we're going to use the graph builder tool and include the 5-number summary. I think that's got it. Good stuff right there. And yeah, double check your things. Did you take a proper screenshot? Did you include the 5-number summary? Write up description of the nature of relationship between the box plots. Use differences and similarities between them. And we'll have to include numeric information again. And that's probably one of the biggest things people don't do is they don't include the numeric information. So let's go do it. We need a random sample of 100 plus the last 2 of our UTID. Have the roller coaster data open. I'm going to go here to table subset. Table subset. Under table subset, you're going to go to random sample size and 100 plus the last 2 of your UTID. Bivariate, exactly. So to make side-by-side box plots, we need an X variable that is what? To make side-by-side box plots. Maisie, I don't see it. I don't see it. Resend it again. We're going to take a chance at this. Sloan, I'm going to do something crazy here, Sloan. Tell me if your options change. I'm going to remove you as a mod. Oh, you are a standard mod. I should have just clicked. Okay, so I need to add standard mods. So Sloan, you were one of the mods from now. I went to remove you, but I didn't. But we made Mozzie a mod right there. And I need to make people standard mods. Well, that answers the question of what mod I need to make you because it says you're a standard mod. I just answered my own question by almost removing you as a mod, Sloan. But Maisie, you're now a mod also. So hopefully nothing gets blocked because maybe YouTube or Google or someone didn't like it. I don't know. So to make side-by-side box plots, no computer can remind me where the instructions for downloading jump are. Yeah, I heard they might be on the visual playlist. If not, we'll go find it here for a second, and then we'll go find that right after this. So to make side-by-side box plots, how do we do this? To make side-by-side box plots, how do we do this? What is required for side-by-side box plots? What is required for side-by-side box plots? A what X and a what Y. So go to the side-by-side box plots on here and think X has to be this and Y has to be this. You'll use your variables, but this is a learning objective. Side-by-side box plots are stacked histograms to be unmodded. I was going to make you a managing mod so you could tell me what it did. I almost made you like a super duper mod. And then you get your VP, RotoWave. So side-by-side box plots are categorical X, quantitative Y. If you look right here, categorical X is this row right here, and then quantitative Y, so it's a bivariate. Everything up there is univariate, so take a screenshot of this and make sure to know this. So here we are doing our visualization, and I'm going to pick the ticket somebody had. Oh, we don't want that. We don't want that. I'm going to pick the class somebody had. Where's class? Let me put it down here. Need to make that categorical. Passenger class, ordinal. Cool. Just so people don't get confused, I'm going to make it nominal. Green is ordinal. Great job, Sloan, right there. Exactly. We're going to graph builder, and then we're going to go to passenger class. So that put the X variable, and it shows that it's 1, 2, 3, but that's categories. If you notice, it is looking like groups, so I could click something like this right now, but we are going to mix it up a little bit, and we're going to put right here the fare. Now, put your variables there, and then click side-by-side box plots. Let me show that again with a step-by-step process. Go to graph. Go to graph builder. Take your categorical X, which you were told to take, it'll be red, put it on the X axis. Categorical X with the red on the X axis, the one you're told in your assignment to take. Next, you need to take the quantitative Y, the quantitative Y variable of interest, and put it on the Y axis right here. This is kind of a dot plot, just scattered across. So it is a dot plot. It's side-by-side dot plots. But we're going to go over here to the box plot option right there. And then we are going to add to it the 5-number summary right here. You might have to scroll down. It's a little hard to see that. You might need to increase the size, but put the 5-number summary right there. And then we're going to make it look all pretty right here doing this. And then make sure to click done. A lot of people forget to hit done right there. And yeah, whoa. What's really interesting to you about first class tickets? We're going to delete that. And let's say class of passenger. Did I spell passenger? And passenger class by, or fare by passenger class. Yeah, there it is, and there it is. And then cost of ticket. That's good right there. What do you notice about some first class, which is pretty crazy? I would have never guessed that. I had no idea about that. There were people in first class who paid nothing. The minimum price in third class was more than nothing. So there were people in first class who got on for free, and then there were people in third class who still had to pay a little bit of money. But first class, if you notice, has a Q1 right there. So 25% of people are at or below this. There are only 20 first class people in our sample, where you see there's really an increase to Q1 especially. There's definitely a strong relationship here, but really weird that the min of third class is not 0. Might be our sample. There might have been someone who didn't pay anything for third class because we took a sample of all the Titanic data. But that's some interesting stuff right here. But probably the biggest concerns for us and what we would talk about, and there's our good screenshot. We bring it over to our graphic. We're going to make it look nice and pretty right here. And how much time we got? We got 10 more minutes. Good. And we're going to go right here. And there we go. Looking good. We're going to center it with the little center under the home right there. And then talk about stuff. Okay, so what would be a good way? How much would it be in today's money? Okay, so let's look at the median third class ticket. Okay. When did the Titanic crash? 1909. Okay. What is $10 in 1909 dollars in 2023 dollars?
Here's what I found.
Here we go. It's saying $10. No, it's saying 100 is worth. Okay, so it says $100 is worth. God, that's insane. It's saying that's what it's worth. So the inflation is about 32 times. So these people right here paying that, you gotta be kidding. No way. They were paying about $6,000. They were dropping 6K, 7K on that. Even third class would be nowadays $200. But I mean, $200 for a cruise or something right now would be pretty cheap, you know? You're like a $200 cruise, but then people up here are paying about 70 and 32, so they're paying $2,000. So it was somewhere between 200 to 2,000 there. I don't know. Sometimes I wonder about these inflation calculators, and I'm like, well, I don't know. Money. My parents bought the first house for like $35,000, which that house up in New York sells for $500,000 now. So yeah, things go a little bit crazy. $0 is still $0. We know what that's worth today. But what do you notice is some big differences right here to talk about. Make sure to do a thorough write-up of your report, and I would not skimp on your words on this. I would start comparing these, and that's pretty big right there. Some drastic difference between the 50th percentile of what people were paying per tickets by class. The 50th percentile of first class was $79.2. Which is about 3 times higher than the second class, which was $24 for the 50th percentile, which is also about 3 times. So there's a factor. It's really neat to me, which I would comment on. Does everyone notice, or do you notice right there, Sloan? There's a factor of 3. Like if you do 3 times 8, it's 24. 3 times 25 is 75. So there's almost a factor of 3 increase between the medians right here. So every time you're doing this, you're getting like a 3 times factor increase, which is pretty interesting between the medians. So that's, that's a pretty good comment right there, I would say, which I didn't expect to see that in the data. We just look at it. You also notice that when you go between the classes, there's a lot more what in the data, which another thing to note is there's a lot more what in the data right here. What would we call this? I mean, I know what that is. Mathematically, it's going to be this right here. And what is this a measure of? You might try to, put this in sections. My first comment would be on comparing the medians. The big thing to do right here is to compare them. So you don't want to just list off everything. You want to compare and contrast. And when you look at the IQR, it's a measure of what? And great job right there, Sloan. The IQR is a measure of, and think of the S word that it is, the IQR is a measure of what of the data. So the idea is not to just list all the values and say this is the this, this is the this. The idea is to compare and contrast, which I'm going to do right here by computing the IQR for each, and that will allow me to compare the what of the data. Think of the S word that IQR measures. Shape, center, and then the last one is what IQR analyzes for us. So IQR is a metric of how what out the data is. Not shape. Good answers. It's based on shape. If we have outliers and stuff, we'll use the IQR, which there is some outliers in this data. So IQR seems pretty good for a measure of spread. So the spread right here is being measured by the IQR. And think about this. And great answer, Sloan, right there. So IQR is a measure of spread along with standard deviation and range. When we calculate the IQRs right here, I'm going to do some quick calculations. This is about 8. That's about 14. And that's about 43. I would take the decimals. Please listen to me. Take the decimals. Take all your decimals, carry through, and do like 93.5 minus 50.1. And there's the actual IQR. So with this right here, when we look at this, there's a lot more variation, like comparing the IQRs. First class has an IQR of 43, second class has an IQR of 14, third class has an IQR of 8. It's clear to see that there is more variation in the ticket prices of wear, which you can also see it visually. It's clear to see that there's more variation in the first class tickets, I'll say it. Also, interestingly enough, half of first class, this is a good observation, over half of first class, because you could talk about the median that way, paid more than anyone in second and third class. And you can talk about the mins. It's weird that the min for third class is not 0, where the other ones have mins. The maximums of second and third class are below the median of first class, indicating to us that over half of first class paid more than everybody in second and third class on what they paid with this sample. Does that make sense, Sloan, right here? There's no exact things you need to say. You don't just want to list every value, though. Like, it's interesting that over half of first class, because I put that right where the median is, over half of first class paid more than everybody in second and third class, because that's the maximum for third class in our sample. And that's is it Yeah, it is. It is. I was looking at it 69 up there. And that's the maximum right there. And you can see it that the maximums right here are below the median right there. And that's the kind of comparisons we're looking for. Like that's where you've done it. I'd look at the medians, compare those. I'd look at the IQRs for measure of spreads, compare those. I'd look for max and mins for unusual things. Like you might even mention the person who paid the most for a ticket right here is $211.50. And what's really cool about this is we could go, and I'm going to finish off here. We could go and find all about that person over here by going to Titanic, and we go to which dot max of Titanic fare and report that row. And that person survived. It was Miss Annie Ward, 35 years old. No, she was all by herself. Who was Anna Ward? Who was Anna Ward? Anna Ward Titanic. We got to find this out to end. So we got to look up Anna Ward Titanic. Anna Ward Titanic. Who was she? Anna Ward Titanic. Annie Moore Ward. Here she is right here. There is Annie Ward. I got 4 minutes. She lived to 81. There's a dog right there. What is? Oh, I don't like this site anymore. It's just random ads. But Titanic fandom. Okay, this might not have random ads. There is the individual right there. More ads for scales. Oh my gosh. Can we go to sites that don't have ads? 35 years old. I don't know what's going to appear with ads, so I got to leave the sites. And then we put our own opinion in there. Not all. Yeah, just write your own opinion. Walk through it. Who was she? Was the maid of Condar's family who traveled in first class. She was the maid on Lifeboat 3. Huh. She's a maid. Huh. But that's not the full. Is that the full data set we just used? Did I just use the full data? I did use the full data set, didn't I? She had the most expensive ticket on the Titanic. At least from this data set, it says. So that's weird. Her fare was $512. It's not in our random sample. Yeah. Interesting, right? That's a fun fact we just learned, that the most expensive ticket, and she didn't have any siblings, didn't have any parents on the Titanic because she was a maid. See, that explains why no siblings, why no parents. I thought she was like a celebrity or something, like a high class person. But nice to know she survived. There's her ticket number. Yeah, cool stuff right there. Well, that's got it. Fun analysis. That's what we like to do here. And I love that you can do codes like this, which.max. This just finds which was the max. It finds the position. So I was able to find them in the data set and return that row. Yeah, I'm meant to do this stuff in Jump. You could do it in Jump pretty quickly. We just go to our Titanic data set right here. And it's going to get mad when I sort this. It's going to say, got to open a new thing. Sort, descending, open a new thing. And then you could go right here. Oh, paid the most. Here we go. Whoever that was. Yeah, good deal. Well, until next time, bye for now, everyone. Bye.